Hello everyone, welcome back. In this video we're going to talk about how to solve a compound inequality. A compound inequality is made up of two inequalities connected by either the word and or the word or. In this video we'll focus on compound inequalities connected by the word and. To solve a compound inequality with and, we follow these steps. Step 1. Solve each inequality separately. Each inequality will have its own solution set. Step 2. Graph each solution. The solution to the compound inequality will be the numbers that make both inequalities true, which is the intersection of the two solution sets. This graph shows the solution to the compound inequality. Step 3. Write the solution in interval notation as required. Let's get started with example 14. We are asked to solve the following compound inequality and write the solution in interval notation. X divided by 4 is greater than or equal to -1, and -4 x minus 4 is less than or equal to -3. We'll solve the two inequalities individually. For the first inequality, x divided by 4 is greater than or equal to -1. We multiply both sides by 4 to eliminate the fraction. X is greater than or equal to -4. This is the solution to the first inequality. Now we graph it. We place a bracket at -4 because the number is included, and we shade the line from -4 all the way to positive infinity. This is the graph of x being greater than or equal to -4. Now for the second inequality, -4x minus 4 is less than or equal to -3. We add 4 to both sides to simplify. -4x is less than or equal to 1. Next, we divide both sides by -4, remembering to reverse the inequality sign since we're dividing by a negative number. This gives us x is greater than or equal to -1/4. Now we graph this inequality. -1/4 is between 0 and -1, closer to 0. We place a bracket at -1/4 since the number is included and shade the region to the right, indicating that x is greater than or equal to -1/4. To find the solution to the compound inequality, we look at the intersection of the two graphs, which is the region where both inequalities overlap. This region starts at -1/4 and extends to positive infinity. So the solution in interval notation is from -1/4 to infinity. Now let's solve example 15. We are asked to solve the inequality 7 is less than 2x plus 3, which is less than or equal to 13, and write the solution in interval notation. This is also an and problem, which means we are dealing with two inequalities. Inequality 1, 7 is less than 2x plus 3. Inequality 2, 2x plus 3 is less than or equal to 13. We solve each inequality separately. For the first inequality, we subtract 3 from both sides. 2x is greater than 4. Then we divide by 2. X is greater than 2. Next, we graph this inequality. Since x is greater than 2 but does not include 2, we place a parenthesis at 2 and shade the region to the right. For the second inequality, we subtract 3 from both sides. 2x is less than or equal to 10. Then we divide by 2. X is less than or equal to 5. We graph this inequality by placing a bracket at 5 since 5 is included, and shading the region to the left. To find the solution to the compound inequality, we look for the intersection of the two solution sets. The overlap occurs between 2 and 5. So, the solution in interval notation is from 2 to 5, with a parenthesis at 2 and a bracket at 5. I hope this helps you understand how to solve compound inequalities involving and. Thanks for watching, and I'll see you in the next video.